Hi, my name is Natalie Grundy and this is assignment 2 of 2 for Introduction to Data Analytic Practices. This is a presentation and explaining the dataset and report for this particular project. So as part of a healthcare data analytics team, we are working on a project to use patient data to improve the early detection of heart disease. This project aims to analyse the data, uncover patterns and trends, build visualizations, and communicate insights that support early diagnoses. Using data mining techniques, machine learning, modelling strategies such as logistic regression and decision tree, and data visualization, the dataset can assist in finding high-risk patients. So the overall objectives are to improve early detection of heart disease and by using patient data to enhance any decision making. Looking at the dataset overview, so this dataset contains the details of 1,000 patients. These patients have the following 9 variables which outline the data types they each consist of. Age is numerical, so this is the patient's ages which range from 30 to 80 years old. Sex is categorical, and this contains the biological gender of the patient which is displayed as male or female. Blood pressure is numerical. This shows the blood pressure in mmHg from 90 to 180. Cholesterol is numerical. This shows the cholesterol in mg/dl from 150 to 300. Smoking is categorical, so this will state whether the patient smokes with yes or no. Physical activity is categorical, providing the patient's activity level displayed as low, moderate, or high. ECG results are categorical, and this will show ECG test results as normal, abnormal, or probable. Heart rate is numerical. This shows the resting heart rate in beats per minute as 60 to 120. And finally, heart disease is binary, which shows the target variable where 1 equals at risk and 0 equals not at risk. Continuing to look at the dataset overview, so as shown here in figure 1, this is the dataset view, and by performing df.head will provide a snapshot of the first 5 rows of data, and it will display how the information is being recorded. So as you can see in this image, each column is clearly titled along the top with the age, sex, blood pressure, etc. And each row going down represents the individual patient data. So you can see in the columns there how the data will look with the specific data types as explained in the previous slide. Here in figure 2 we have a heat map correlation. So this shows the correlation between all figures within the data set and how they correlate with each other and with heart disease. So on the right you can see the meter, which starts from below 0 at dark blue up to 1, which is red at the top. The dark blue will show the weakest correlations, whereas the red at the top will show the strongest correlations. So as you can see going down diagonally, it will always show as red because it joins up with its same particular column. So you can see at the top box where age is, it links with age, shows a 1, and then going down diagonally within each column. So looking at the feature correlation with heart disease, you can see that it's highly correlated with cholesterol, blood pressure, smoking, and heart rate. You can see These are in the light blue colour, which would show halfway up the meter, which shows the strongest correlations with heart disease. And it will show the increase of a higher likelihood of the risk in heart disease, linking with these specific categories. So the weak correlations, which are age, physical activity, sex, and ECG results, which are shown in a darker blue colour, which define at the bottom of the meter, which shows they are the weakest correlations. So although they are not directly connected with heart disease, they could still be influenced when linked with other factors within the data set. So through testing with the same patients, as shown here in figure 3, it shows that around every 3 people there is no risk of heart disease, and it shows 1 person shows a risk of heart disease. This provides non-biased results as each test showed the same results, and it also shows that the model can identify each case equally. So approximately 71.5% have no risk of heart disease, and approximately 28.5% have a risk of heart disease. And in this graph you can see that it's clearly titled, the axes are labelled for easy readability. So next, looking at data preparation, which is essential to be completed before delving into looking at decision making and predictions. There are a few steps that need to be implemented which will ensure a clean data set. So first is important to upload the specific data set. So as you can see, df equals pd.read_csv is how to upload the data set, followed by the path of where the data is being uploaded from. For this particular report, we use Python within Google Colab. Next, as explained in one of the previous slides, using df.head is important to pull through the first few rows of data. This will define what the column names are and how the overall data will display, and also to check everything looks as it should. Next, you would look at the df.info selection. This will break down each column's specific data type, detailing each column's header name and how many entries there are in total. So Ilias and Chu in 2019 explained that the most essential step in data cleaning is to find and fix errors. Errors can be completed with a mean, mode or median value to complete the data set, or the column can be removed if it would lead to the skewing of the data set. So checking for missing values is important. Using df.isnull.sum, we'll find which columns contain the missing values and how many there are in total per column. Here are some images to show what's just been discussed as how they will look once implemented into the application. So in figure 4, this is how it would look when you upload the specific data set. As this data set is heart disease data, you can see in the brackets that's where it's pulled through from the path of where it's being uploaded from. In figure 5, this is the df.head, and you can see there that it clearly displays the title of each column across the top. For example, age, sex, blood pressure, cholesterol, etc. And the rows going down show each specific data type and how it would look. Next, df.info in figure 6 shows the total number of entries, which is 1,000, and we have 1,000 patients, so that is correct. And it shows whether there is a null count within any of the columns. And as you can see here, all columns have been completed in full. It also defines the data types, where you have 5 columns as integers, and 4 columns are objects. Next, in figure 7, this will display the missing values. So using df.isNull.sum will show the columns and how many missing values are in each column. As you can see in this data set, there are no missing values. So once all these steps have been completed, you can then be sure that the data set is as accurate as it can be. This will allow for further investigation into the data set to get the correct prediction and decision-making outcomes. Applying pre-processing techniques helps to improve the data quality, clean the data. It will ensure time saving and help to reduce any bias. Combining feature engineering steps into this will also help the data to be understood and allow experimenting with different techniques and enable the assessment of techniques used using different models. So looking at the machine learning models, in this report we use logistic regression and decision tree. So logistic regression works well with continuous data and decision trees work well with categorical data. As you can see here in figure 8, the model comparison table from Geeks for Geeks in 2019 shows when a model is best suited and some challenges that could be faced. So for example, a decision tree is prone to overfitting, whereas logistic regression is not. Logistic regression may be less interpretable, whereas decision tree may be more interpretable. So although neither model is better than the other, it helps to look at these pros and cons to ensure you're getting the most accurate results possible and identifying which model will support the decisions that need to be made. So looking further into the models used within this report, so on the left-hand side in figure 9, the logistic regression confusion matrix shows that it correctly predicted 136 patients not having heart disease, and 47 patients were correctly predicted as having heart disease. It also incorrectly predicted that 11 patients had heart disease when they did not, and 6 patients with heart disease were incorrectly predicted to be healthy. This model shows a high precision rate but could also be improved further. Next, on the right in figure 10 is the decision tree confusion matrix. This shows that it correctly predicted 146 as no heart disease, 1 predicted as having heart disease when they did not. It correctly predicted heart disease in 53 patients and showed 0 missed cases. This model shows a high precision percentage, which could suggest overfitting in the tree, and further accurate precision was found once cross-validation was performed. So looking at the classification reports for both models, as you can see on this slide, in each column, the heart disease defined as yes or no, the accuracy column, which is how accurately the model performs. The precision column shows how precise each model is with predicting the correct outcomes. The recall column, which can count how many times the model predicted the correct result. And the F1 score is the average between accuracy and recall. So the higher the percentage, the better the result for the models to predict the right outcomes and results. So as you can see in figure 11, in the logistic regression model, it scored well overall across the board with reliable results. And as shown in figure 12, the decision tree model showed almost 100% accurate results, and further investigation revealed that this could be due to overfitting. So looking at the decision tree, so the default tree accuracy, as explained in figure 13, was 98% accurate. So performing cross-validation, which reduced overfitting and changed the accuracy in results. So as you can see, when the depth was reduced to a shallow tree, the accuracy changed to 80%. This gave more accurate percentage rate and provided better overall prediction results. So based on both of these models, logistic regression is more suitable as it provides an accurate prediction without the risk of overfitting or the need to perform cross-validation. Although the decision tree performed better on results, cross-validation showed overfitting issues, whereas logistic regression showed overall strong reliability, which is essential in this particular dataset to provide real-world predictions. So next, it's important to tailor any data for specific audiences. So choosing the right visualizations is important to match the audience. So you need to look at the complexity of the data, of what the data is portraying and how it needs to be delivered. If the audience is non-technical, for example, it is essential to keep all visuals clear, simple, readable, non-complex, and to the point. This will ensure overall full understanding. However, if the audience has a technical background, then more detailed, in-depth visualizations, reports, and information can be used, as they will understand how to read the data. Bearing all that in mind, regardless of technical background, it is essential to keep all information and visuals simple. This will make sure everyone follows along with ease. So with this particular data set for the heart disease, it is important that the results are displayed as simply as possible. As healthcare staff members would need to be able to look at these visuals, see the results, and understand them. So an example of this would be a simple bar chart, which would be clearly labelled with the axes defining what the data is displaying, a title to show what the count is. This will provide a total count, which simply shows a yes or no answer. So ensuring that titles, legends, and axes are clearly labelled is essential, and choosing the correct graphs and charts which help people to read the information and the predictions easier. So in conclusion, it is essential to look at the data that is being collated, ensuring all information is fully understood. And to do this, data preparation is very important. This will maintain accuracy throughout any project and provide clear communication across all teams, stakeholders, and anyone else involved. Cleaning and checking for missing values will also ensure the accuracy of the results and provide trust that the data is accurate and clear. Incorporating those pre-processing techniques will enable the precision of the results and predictions, giving an overall rounded, trusted data set and visualizations. Selecting the best suited model is vital because this will show that the data is providing the correct results. As all models work as good as the other, it is important to find the model that works best to suit the needs of the organisation, giving clear insights in providing those predictions, results, and decision-making outcomes. Data visualizations need to be kept clear, simple, and easy to read. This will allow easy understanding and everyone to be able to follow along. It will also reduce confusion and any further explanations that should be required, as it will all be clearly outlined within those visuals and insights. So overall, within healthcare, it is vital to take these steps. This will provide accurate predictions and decision-making processes, because when patients' lives are involved, there can be no shortcuts. The data needs to be 100% accurate, and it needs to be able to give those real-life predictions to get the patients the right outcomes. So for future recommendations, there is the option to try the random forest classifier model alongside logistic regression and decision tree. Random forest could offer further insights into the data sets, or it might not, but it would be worth checking against all the models, and that way you can see the pros and cons as to which one would perform best to suit what is required of the particular project. Here is the reference list of the references used within this presentation, and thank you very much.